Hi everyone, let's start paper 1 multiple choice of AS chemistry, May-June 2023, variance 13. Duration of this paper is 1 hour 15 minutes. We have 40 questions in this paper and we need to attempt all of them. The total mark for this paper is 40. All right. Periodic table is given in the question paper, and also important values, constant and standards are printed in the question paper. Let's start question number 1. Propanoic acid is treated with reagent X. So that reagent X is important now at room temperature. The organic product of the reaction is sodium propanoate. If product is sodium propanoate, then it means this propanoic acid is reacting either with sodium metal or sodium carbonate or sodium hydrogen carbonate or sodium hydroxide. All right. So these 4 possible reagents we can use in this reaction. But the most important point is that no gas is produced during the reaction. If no gas is produced during the reaction, then it means we cannot use sodium carbonate, and sodium hydrogen carbonate, because when sodium metal is used, hydrogen gas is given off. When sodium carbonate or sodium hydrogen carbonate is used, obviously carbon dioxide gas is given off. Since there is no gas is produced, which means this reagent X must be an alkali, that means NaOH. All right, and which is why right answer is B. And obviously A is incorrect because it produces carbon dioxide. C is also incorrect because it produces carbon dioxide. And D is also incorrect because sodium sulfate is a neutral salt, cannot react with this acid. All right. So it's a neutral salt, guys. Remember this. Now the next question. The ionic equation shows iodide ions reacting with manganate 7 ions in acidic solution. When iodide ions are basically reducing agents, manganate 7 ions are acting as an oxidizing agent in this reaction, and for acidic solution it is represented by H positive ions, right? The latter all represents whole number. That's a very, very powerful point. So all letters shows the whole number. 2 or more are the same as each other. What is the lowest possible value of V? So examiner is asking for this value. You know, we have done ion electron equations in the class. So I believe you can solve this equation through ion electron rules. Let me apply those rules. First, we need to apply ion electron rules on this conversion. MnO4 negative is converting into Mn2 plus. We have 4 oxygen atom here. So I will use 7 water molecule. Oh, sorry, 4 water molecule. According to the next rule, we have 8 hydrogen atoms. So to balance hydrogen atoms, I will use hydrogen ions over here. We have 8 plus and minus 1. That is plus 7 charge on the reactant side. Whereas we have 2 plus charge on the product side. So I need to balance this charge. So I'll convert plus 7 into plus 2 by using 5 electrons. Okay. So that's my half equation for manganate ions. Similarly, I will solve iodide ions. Iodide ions are converting into iodine molecule. Obviously, we have 2 iodine here. So I will use 2 here. We have 2 minus charge. So I will use 2 electrons here. All right, we need to balance the number of electrons. You know the rule, you know the criteria. I need to multiply 2 with this, and I need to multiply 5 with this equation, all right, so that we can balance the number of electrons. As the number of electrons are balanced, we can cancel out with each other. So the final equation is going to be like this. 2MnO4 negative plus 16 hydrogen ions plus 10 iodines. We have 5 I2. We have 2 Mn2 plus, and we have 8 H2O. Look, all U, V, W, X, Y, Z, all of them are exist in whole numbers, right? So examiner is talking about V. So V is going to be 16. So I believe 16 is going to be the right answer. Okay. I hope it makes sense to you. Next question, question number 3. A piece of rock has a mass of 2 grams. It contains calcium carbonate, but no other basic substances. It neutralizes exactly 36.0 cm cube of 0.5 mole per dm cube hydrochloric acid. All right. What is the percentage by mass of calcium carbonate in 2 gram piece of rock? As we know the concentration of and volume of hydrochloric acid, technically speaking, I can find the moles of HCl. So it's 36.0 into 0.5 divided by 1000. So the moles of HCl is going to be 36 into 0.5 divided by 1000. It's going to be 0.018 moles. All right. Now we need to make the equation. So it's calcium carbonate reacting with hydrochloric acid. Obviously, you will get calcium chloride, which is your salt, water, and obviously carbonate releases carbon dioxide when they will react with any acid. Now, we know that we have 2 moles here. We have 1 mole here. If we have 0.018 moles of HCl, how much moles of calcium carbonate obtained? So we need to divide by 2. So it's going to be 9 into 10 to the power minus 3 moles. So I need to find out the mass. This is moles of calcium carbonate. All right. Now the next step is mass of calcium carbonate. And for that, I need to multiply moles into MR of calcium carbonate, which is 100.1. So it's going to be 0.9009 gram. Examiner is asking for percentage by mass of calcium carbonate. So I've got the mass of calcium carbonate. Now in order to find the percentage, I have mass of calcium carbonate 0.9009. I've got the mass of sample, which was 2 gram. To get the percentage into 100, so divided by 2 into 100, it's going to be 45.045%. So 45.0%, I mean B is going to be the right answer. All right. Question 4. L and M are elements in period 3 of the periodic table. Neither element is argon. All right. So period 3 elements. An examiner is talking about sodium to chlorine in both the cases. All right. So, okay, information about the Pauling electron negativity values of L and M is given. Okay, well, I have given you this Pauling scale in the class. We have discussed this in extreme detail, including factors and all that. Let me give you a hint here. Sodium, magnesium, aluminum, silicon, phosphorus, sulfur, and chlorine. Since examiner is talking about period 3, so I have given you period 3 elements here. All right. The Pauling scale for sodium is 0.9. This is 1.2. Then 1.5. Then 1.8. Then 2.1. Then 2.5. And then 3.0. That was the Pauling scale I have given you in the class. So according to the examiner, element L has the highest 7 elements, has the highest electron negativity value. which means it must be chlorine, because chlorine is the most electronegative element in period 3, right? It has the most electronegativity value. So it must be chlorine. And M is the lowest electron negativity value among these period 3. So which one has the lowest value? Sodium, obviously. So sodium is basically M. All right. 3 statements about element L and M are given. Element L contain covalent bonds. That's right, because element L is chlorine, and chlorine always exists in diatomic state. If it exists in diatomic state, obviously it exhibits covalent bonding. So first statement from my perspective is right. Now the next statement is element L has a higher atomic number than element M. Element L has a higher atomic number. That's also true because chlorine has an atomic number of 17, whereas sodium has an atomic number of 11. By the way, atomic number and proton number is the same thing. So second statement is also right. Let's talk about the third. A compound of L and M contains ionic bond. Obviously, M is basically sodium and L is basically chlorine. So this is metal, this is non-metal. So when so M is sodium, L is chlorine. When they will combine together, obviously you will get sodium chloride, and sodium chloride exhibit ionic bonding. It has a giant crystal lattice structure. So I believe third statement is also right, and therefore A is going to be the right answer. Okay, that's a very straightforward question, guys. Question number 5. Ammonia reacts with acid to form ammoniamides, and that's the equation. We have discussed this equation in the class, all right? Which row is correct? Shape of ammoniamides. Let me draw the structure of ammoniamides here. Nitrogen belongs to group 15 of the periodic table, so it has 5 valence electrons. And obviously those 5 electrons should involve in the formation of a covalent bond. So let's distribute those 5 electrons. 1, 2, 3, 4, and this one is 5. See, ammoniamine has a positive charge, which means nitrogen lost its 1 electron. When it lost its 1 electron, obviously around nitrogen we have 4 single bond and there will be no lone pair. So 4 is going to be the total. If I'll use 4 lines, so obviously first line represents s orbital and the remaining line represents p orbital. So the hybridization is going to be sp3. And you guys know that when we have 4 single bond in a 0 lone pair situation with sp3 hybridization, angle is going to be 109.5 degree with a tetrahedral geometry. The shape is going to be tetrahedral. Obviously option A and option B is incorrect. An angle is going to be 109.5 degree. So this option D is going to be the right answer. That's an easy question, guys. All right. Electron negativity differences can be used to help determine the oxidation number of an atom in the different species. A number of rules are used, which includes the more electronegative element is given a negative oxidation number. That's exactly we have discussed in the class. I hope you remember we have discussed interhalogen molecules, right? When two different halogens combine together, then interhalogen molecules are formed. Let's suppose FCl. So if I need to find out the oxidation state of fluorine, by the way, it is more electronegative than chlorine, right? So let's suppose fluorine is X. Chlorine has a charge of -1 because it is found in group 17 of the periodic table. Since the molecule is neutral, has no charge, which is Y equals to 0, right? Oh, my bad. What a silly mistake I have done. Let's suppose fluorine is X, and in this situation, if fluorine is negative, obviously chlorine should be positive, right? So it must be +1 equals to 0, then X equals to -1. Okay. Hydrogen is more electronegative than group 1 metal. Obviously, if I'm talking about sodium hydride, so obviously in sodium hydride, sodium has positive charge, whereas hydrogen is negatively charged. If hydrogen is negatively charged, obviously it is more electronegative than sodium. Oxygen is more electronegative than hydrogen. That's true. Because oxygen the electron negativity of hydrogen is 2.1 and the electron negativity of oxygen is 3.5. All right. Which row is correct? So we need to consider two different reactions, disproportionation and redox. Let me give you the definition of redox here. When oxidation and reduction occurs simultaneously. Okay. And how about disproportionation reaction? If an element or species is simultaneously oxidized and reduced. A single species is simultaneously oxidized and reduced. So let me talk about this dichromate, this chromate 6 signs. Let's suppose chromium is X, oxygen has a charge of -2. We have 4 oxygen atom into 4. As the overall charge is -2, so equals to -2, then X equals to +6. Over here, we have 2 chromium, so it's going to be 2X. Oxygen has a charge of -2. We have 7 oxygen atom into 7. Overall charge is -2, so equals to -2. Then X equals to +6. All right? Which means in this reaction, there is no change of oxidation state of chromium, right? Which means it is neither redox, it is not disproportionation reaction. All right? Also, here, the oxidation state of hydrogen is +1, that is will remain same. So there is no change in oxidation state in this reaction. So it's not going to be redox, it's not going to be disproportionation reaction. So option is incorrect. Okay, let's talk about B. Over here in sodium hydride, hydrogen is -1, and over here hydrogen is 0, which means in this scenario, hydrogen is actually oxidized. On the other hand, in this hydrogen is +1, and if it is converting into this, which means it is getting reduced, right? So this is right, but this is wrong because it is not disproportionation reaction, because we have two different species involved. According to the definition, an element or a species, a single species, if involved simultaneously in oxidation reduction, then it's going to be disproportionation reaction. But over here, we have two different species involved in oxidation and reduction, which means it is not going to be disproportionation reaction, which means it is incorrect. Next is MnO4 negative. Let's suppose manganese is X. Oxygen has a charge of -2. We have 4 oxygen into 4. Overall charge is -2. Then X equals to +6. Over here, the oxidation state of manganese is +4. Over here, the oxidation state of manganese is +7. So in this single species, manganese is getting reduced and simultaneously oxidized, which means it is redox. Also, it is disproportionation reaction, which means C is going to be the right answer. All right. I hope it makes sense to you. Last question was 7. Which assumptions are made about ideal gas? Ideal gases contain molecules with no mass. Ideal gases contain no mass. The volume of gas is, no, it has some mass actually. It has some mass. So this is wrong. It should have some mass. Ideal gases contain molecule with no volume. This must be the right statement because the volume of gas is negligible. All right, in ideal situation, according to the postulates of kinetic molecular theory. Ideal gases have no intermolecular forces. I've given you the information. There is no attractive and repulsive forces. So this statement is also right. So that means if one is incorrect, obviously A, B, and C is incorrect. Only 2 and 3 is correct, which means D is going to be the right answer. That's an easy question, guys. Question number 8. 200 cm cube sample of water. That is the volume of sample. Okay. The amount of oxygen has a volume of 6 cm cube. When measured at this pressure and temperature, what is the concentration of oxygen gas in the water? Oxygen gas behaves as an ideal gas. Okay. So first of all, let me apply PV equals to nRT. I have to find out the number of moles by using this equation. I know the pressure, which is 1.00 into 10 to the power 5. Volume is given in 6 cm cube. I have to convert it into meter cube. So according to my perspective, it must be 6.00 into 10 to the power minus 6 meter cube. Okay. All right. So it's basically 6.00 into 10 to the power minus 6 divided by R value is fixed, which is 8.31. And how about the temperature? Temperature is 35 degrees Celsius. So in 35, we need to add 273 to get the value in Kelvin. So 273 plus 35, my bad, 273 plus 35 is going to be 308 Kelvin. Okay. So let me calculate this. 1 exponent 5 into 6 exponent minus 6. It's 0.6 divided by 8.31 into 308. 0.6 divided by answer is going to be 2.344 into 10 to the power minus 4 moles. Okay, I need to find out the concentration of oxygen. So in order to find the concentration of oxygen, moles over volume. Okay. Now we have got the moles, which is 2.344 into 10 to the power minus 4. And this volume is in cm cube. I have to convert it into dm cube. So 1 dm cube equals to 1000 cm cube. So if I have 200 cm cube, so how much dm cube we have? So 200 divided by 1000 is going to be 0.2 dm cube. So let me multiply with 0.2 dm cube here. So concentration of oxygen is going to be 2.344 exponent minus 4 divided by answer. So it's 1.172 into 10 to the power minus 3 mole per dm. Is there any option given? Yes. The right answer is going to be B. Question number 9. Which statement explains why Buckminster fullerene has a lower melting point than graphite? By the way, Buckminster fullerene has a simple covalent structure, exhibit covalent bonding, has a molecular structure, and it has a molecular formula of C16. It has a lower melting point because it is a simple molecular structure. If it has a simple molecular structure, obviously it exhibits weak van der Waals forces. Has weak van der Waals forces, also called intermolecular forces. also called London forces, also called London dispersion forces. All right. So option A, Buckminster fullerene exists as a discrete molecule. That's exactly the statement, that it has a simple molecular structure with weak intermolecular forces, with weak van der Waals forces. I think A is going to be the right answer. Let's talk about option B and C and D. Graphite is partially ionic, not at all. It is not ionic, it is covalent, which is why B is incorrect. Next is carbon-carbon bonds. In Buck, we are not breaking the covalent bonds. All right. So we are just breaking the van der Waals forces, which means this option has nothing to do with the melting point, and therefore it is incorrect. Mobile electrons in graphite means it has a metallic structure. That's an insane statement because graphite exhibit covalent bonding. It has a giant covalent structure instead of metallic. Because graphite is an allotrope of carbon, it is not metal. Obviously, D is also incorrect. Now, the next question is, which equation represents the reaction whose standard enthalpy change is the standard enthalpy change of formation of water? I have given you this example. According to the definition, one mole of compound is formed from its constituent elements. Okay, so according to the first, 1 mole of compound is formed. This must be incorrect because it is 2 mole. This must be incorrect because 1 mole of compound is formed from its constituent elements. So these are the ions, which is why C is also incorrect. Okay. Elements, constituent elements. So option D is also wrong because these are the constituent atoms, not the elements. It has to be H2, it has to be O2, which is why B is going to be the right answer. From its constituent elements in their standard states, under standard condition. Okay, so look, this is 1 mole of compound is formed from its constituent elements because both of them exist in diatomic state under standard condition. Under standard condition, hydrogen is gas. Under standard condition, oxygen is gas. Under standard condition, water is liquid. How many hydrogen here? 2. So we need to put 2 here. How many oxygens here? 1. We need to put half here, which means it is 1 mole of water is formed from its constituent elements under standard condition. So this equation follows the entire definition, and therefore B is going to be the right answer. I hope it makes sense to you. Let's start question number 11. Which mixture will react to form exactly 1 mole of water? Exactly 1 mole of water, okay? So 1 mole of water is formed when hydrogen ions and hydroxide ions are reacting together, converting into 1 mole of water. So when you have equal moles of hydrogen ions and hydroxide ions, then you will get 1 mole of water. Equal number of moles of hydrogen ions and hydroxide ions, then 1 mole of water is formed. One more thing. In this question, I'm using H2SO4, and H2SO4 is a dibasic acid. So when you ionize this H2SO4, it is converting into 2 hydrogen ions and a sulfate ions, which means The molar ratio between H2SO4 and hydrogen ion is 1:2. So whatever you will get in these options, you need to multiply those values by 2, all right? In every case, in every option. Also, sodium hydroxide is a strong alkali. When it ionizes, obviously it will give you hydroxide ions and sodium ions, all right? So this is 1 mole of hydroxide ions, but this is 2 moles of hydrogen ions. So we need to convert it into 1 mole of hydrogen ion, right? So we need to do some sort of working for every option. Like we know the concentration of acid, we know the volume, which is 250. To convert it into moles, we need to divide by 1000. So I'll get the moles of H2SO4, right? And since it has 1:2 ratio, so whatever the value I will receive from this calculation, obviously it's going to be multiplied by 2 in order to get the number of moles of hydrogen ions. So multiply with 2, you will get what? Let me do this calculation in a proper way. For option A, we have 250 cm cube of H2SO4. We have 2 mole per dm cube H2SO4 divided by 1000. Obviously, I will get moles of H2SO4 to 250 into 2 divided by 1000 into 2 divided by 1000. So it's going to be 0.5 moles of H2SO4. Since H2SO4 and hydrogen ion has 1:2 ratio, so if we have 0.5 mole, obviously hydrogen ion is going to be 1 mole. So this will give you 1 mole of hydrogen ion. Okay. Let's talk about the NaOH things. We have the concentration, we have the volume. So moles of NaOH. So it's 500 into 1 divided by 1000. So moles of NaOH. 500 divided by 1000, you will get 0.5 moles. So I need the same number of moles. But over here we have 1, over here we have 0.5. So it's not the equal number of moles, which means from this option, I cannot get 1 mole of water, which means option A is incorrect. Let's talk about option B. We have 250 cm cube volume of H2SO4. Concentration is 2 divided by 1000. Obviously, I will get 0.5 moles. All right. And as per equation, we have 1:2 ratio. So if we have 0.5, obviously it's going to be 1 mole of hydrogen ion. All right. That's the same criteria, guys. My bad. This is 2:1. Okay, but this is 1 mole again. 1 mole hydrogen ion. Let's talk about this one. This is 1000 into 1 divided by 1000. Obviously, it's going to be 1 mole. So from here, I'll get the 1 mole of hydroxide ions. From there, I will get the 1 mole of hydrogen ions, which means B is going to be the right answer because we are getting the equal number of moles in both the values. Okay. I can give you the answer for C. No issue at all. Let me give the calculation for C. Concentration is 2 mole. Volume is 500 divided by 1000. Obviously, it's going to be 1 mole. Since H2SO4 and hydrogen ions has 1:2 ratio, so if we have 1 mole, obviously hydrogen ion is going to be 0.5. Okay, so from here I'm getting 0.5 moles of hydrogen ion. Let's talk about NaOH. we have 500 into 1 divided by 1000. So I believe we are getting 0.5 moles. Oh, 500 into 1 divided by this. So we're getting 500. 500 into 2. Wait, 500 into 2 divided by 1000. You will get 1. Oh, my bad. This is not 0.5. This is 2. This is 2 moles of hydrogen ion. Okay. This is not 0.5. This is 2 moles of hydrogen ion. You guys have to be very, very careful during calculation. Okay. 2 moles of hydrogen ions. So over here we have 2 moles. Over here we have 0.5 mole. Again, this option is incorrect. Same here. This option is going to be incorrect. I hope it makes sense to you. But that's a tricky question, guys. Let's move on to the next question. That is question number 12. The enthalpy change for the neutralization of nitric acid with NaOH is minus 57 kilojoules per mole. Okay, so we know the delta H value. We know the delta HN for reaction between these two substances, which is minus 57.0 kilojoules per mole. All right. Well, we have 1 kilojoule equals to 1000 joule. So when we have minus 57.0 kilojoule, it's going to be how much? 57 times 1000 is going to be minus 57,000 joules, right? First thing. Second thing, ratio between nitric acid and NaOH is 1:1 because nitric acid is a monobasic acid. Now the next part of the question is 20 cm cube of 4 mole per dm cube nitric acid is mixed with 30 cm cube of 2 mole per dm cube NaOH. Since the concentration and volume of both are different in both the situation, both the substances, which means we need to find out the moles of each substance. So let's find out the moles of nitric acid from here. The volume is 20. The concentration is 4 divided by 1000. I'll get the moles of HNO3, which is 20 into 4 divided by 1000. You will get 0.08 moles. Okay. Similarly, let's find out the moles of NaOH. We know the volume, which is 30. We know the concentration, which is 2. Let's divide it by 1000. I'll get the moles. So 60 divided by 100,000 is going to be 0.06 moles. All right. As both of them exist in 1:1 ratio, so let me give you the information from here. And that information indicates that this has less number of moles, which means, and this must have more number of moles, which means it is limiting reactant, whereas nitric acid is in excess. Okay, this must be in excess. Whew. The initial temperature of both solution is 25 degrees Celsius. So I've got T1 from here, but obviously so far I didn't get the value of T2, which I assumes I need to find out. So we need to find out the final temperature, that is T2. We need to find out, okay? It can be assumed that the heat capacity of the product mixture is 4.2 joule centimeter inverse centigrade inverse, and that there are no heat losses. Okay. So first of all, delta Q equals to mc delta T. M is mass of solution, and mass of solution is always equals to volume of solution, because 1 gram is always equals to 1 cm cube. So we have 20 cm cube, we have 30 cm cube. So total we have 50 cm cube solution, which means it is equals to 50 gram. Specific heat capacity is 4.2. Temperature change is basically T2, which I need to find out, minus T1, and T1 is given, which is 25. So that's my delta Q. Now in the second step, we have delta H equals to minus delta Q over number of moles. And since NaOH is a limiting reactant, so I will use its number of moles minus delta Q. Delta Q is 50 times 4.2, then T2 minus 25 divided by the number of moles, and the number of moles of NaOH is 0.06. So from here, I'll get the T2 value. So T2, so from here, T2 is 16.3. All right. So initial temperature is 25, final temperature is 16.3. Sorry, T2 is 16.3. So temperature change, final temperature. So final temperature. So initial is 25 degrees Celsius. That's 16.3. So final temperature is going to be 41.3 degrees Celsius. All right. I hope it makes sense to you. Okay. So 41.3, is there any? Yes, A is going to be the right answer then. Okay. Whew. Some bond energies are listed. 1 mole of hydrogen reacts with oxygen to give water vapor. By the way, it has to be 1 mole. So it must be like this: H2 gas plus half 2 gas, arrow H2O, water vapor. So it has to be gas. Okay. And we need to find out the delta H for this reaction by using the bond energy data. And the bond energy data is extremely easy. We have reactant minus product. So we have hydrogen. Hydrogen has a bond energy of 436. We have oxygen. Oxygen has a bond energy of 496. Okay. Oxygen has a bond energy of 496. Since it is half, so into half, this is my reactant minus product. Product is water. I mean steam. Steam has 2 OH bond. This one is the first OH bond. This one is the second OH bond. So obviously we have 463. We need to multiply by 2. Okay. So it's basically 684 minus 926. So delta H is going to be how much? Minus 242 kilojoules per mole. Minus 242, I mean C is going to be the right answer. Which which particle contain nitrogen is the same oxidation state and as this ion? So first of all, let's find out the oxidation state of nitrogen in this ion. It's 2x because nitrogen is 2 in the formula. We have 2 oxygen, so oxygen has a charge of minus 2. We have 2 into 2, overall charge is minus 2. Then 2x equals to, I think, plus 2, and then x equals 2 plus 1. So I need to find out the oxidation state of nitrogen in this example. All right. And answer is going to be the one which shows plus 1 oxidation state. All right. So let's find out. Let's find out what is the oxidation state of nitrogen in this molecule. So let's suppose nitrogen is X. Hydrogen has a charge of plus 1 into 2 because 2 hydrogen atom. Fluorine is more electronegative element, and so it has a charge of minus 1. Molecule is neutral, equals to 0, then X equals to minus 1. Obviously it's going to be incorrect because we need to get the plus 1 answer. All right, we need to get the value +1. Let's talk about this one. We have 2 nitrogen, so it's going to be 2x. Oxygen has a charge of -2. We have 4 oxygen atom into 4 molecules neutral equals to 0. Then 2x equals to 8. Then x equals to +4. Again, it is incorrect. Okay, now let's talk about this one. Nitrogen is x, oxygen is -2. We have 3 oxygen atom into 3, whole charge equals to -1, then x equals to +5. Again, this is also incorrect. If A, B, and C is wrong, obviously D is going to be the right answer, but let me give you the calculation. Solution criteria. Let's suppose nitrogen is x, hydrogen has a charge of +1, fluorine has a charge of -1 times 2, molecule is neutral, which is y equals to 0. Then x +1 -2 equals to 0, then x equals to +1. So that's the oxidation state I was looking for, because the oxidation state of nitrogen in this ion is +1, and so in this molecule, and D is going to be the right answer. Let's move on. Question number 15. Question number 15 is easy. Sulfur dioxide reacts with oxygen as shown. This is going to be the contact process, and the enthalpy change for contact process is negative, which means it is exothermic. So this reaction is exothermic. I mean to say forward reaction is exothermic. Forward reaction is exothermic, which means backward reaction is endothermic. Okay. Which change will move the equilibrium position to the right-hand side? Right-hand side. So if equilibrium position move towards the right-hand side, then it means reaction favors towards product side. And change the value of the equilibrium constant Kc. By the way, the value of the equilibrium constant Kc changes only if temperature changes. Because Kc and Kp are only temperature dependent. Its value only changes if temperature changes. So I'm looking for the temperature thing. This must be incorrect, because catalyst never change the position of equilibrium, has no impact on the equilibrium position. So option A is incorrect. B is also incorrect, because Kc is only temperature dependent. It's not depend on the pressure. So it's obviously, I mean to say that if we increase the pressure, obviously equilibrium favors towards right hand side, and obviously the yield of sulfur trioxide increases, but pressure has no change on the value of equilibrium constant, which is why I need to cancel this option. Now C is going to be the right answer, I must say, because for an exothermic reaction, if we decrease the temperature, then according to Lee-Schuster's principle, equilibrium favors towards right hand side. First thing. Second thing, since equilibrium favors towards right hand side, so obviously amount of product increases. If amount of product increases, obviously Kc ki value also increases. That indicates that the decrease in temperature also changes the value of the equilibrium constant. I hope it makes sense to you. Question number 16, guys. Oh my goodness, that's the titration curves, I think so. But my favorite. Solution X and Y both have a concentration of 0.1 mole per dmq. a fixed volume of solution X is added to a conical flask. Solution Y is added from the burette to the conical flask. A titration is performed. That's a titration curve actually. The pH of titration curve for the acid-base reaction between the solutions. All right. What are the solutions X and Y? First of all, look at this value. This must be something around 11.1. The pH is 11.1. And I've told you in the class, this pH shows weak alkali. And weak alkali includes aqueous ammonia, which is also called ammonium hydroxide, and calcium hydroxide. So solution X must be Okay, so solution X must be ammonia because it is a weak base. Obviously, C and D options are absolutely incorrect. On the other hand, look at this value. This value shows the pH 1. And the pH 1 indicates that this is a strong acid. And a strong acid could be HCl, H2SO4, or HNO3. So let me check what sort of solution Y. Nitric acid is strong, nitric acid is strong, ethanoic acid is weak. So right answer is going to be an A, which means this is the titration curve between weak alkali and strong acid. If you remember, I have discussed this in extreme detail in the class, and I have given you this sketch as well, how to plot this sketch and how to get this vertical section of the graph. We have discussed in such a detail, right, in the class. So this titration takes place between weak alkali and strong acid. And obviously this solution Y is your acid. If solution Y or acid has to be on the x-axis, this means it must be in the burette. That means this alkali has to be in the conical flask. Okay. Question number 17. Which row shows the expected properties of the element astatine when compared to the properties of the element iodine? Electron negativity of astatine compared to iodine. We know that down the group, electron negativity value decreases. En value decreases, which means astatine is less electronegative element than iodine, and therefore B and D is our options are incorrect. Next is volatility of astatine compared to iodine. I have told you about this as well in the class. Fluorine, chlorine, bromine, iodine, and astatine. So when we move from top to bottom in a group, number of electrons increases, strength of van der Waals forces also increases, and volatility obviously decreases. And remember, iodine and astatine both are solids at RTP, which means they are less volatile. So volatility of astatine is lower, then iodine, which means these two options are incorrect. The right answer is going to be obviously C. Okay. I hope it makes sense to you. Question number 18. The rate of an exothermic reaction. So if reaction is exothermic, energy releases. And the most important thing is okay, the more energy releases, the higher the rate of reaction. The higher the rate of reaction. Anyhow, by measuring the concentration of a reactant at regular time interval. So according to my lecture, when we talk about concentration versus time graph, so for reactant, concentration obviously decreases, product concentration has to be increases, right? During the experiment, the temperature of the reaction mixture is not controlled. That's a very, very powerful statement. If the temperature is not controlled, obviously temperature changes mostly during the reaction course, all right? And that means the temperature is not going to same throughout the experiment. So obviously rate is not going to same throughout the experiment. So rate changes throughout the experiment. Now option A is incorrect because rate is constant here, which is not possible because it changes over the course of reaction as temperature is not fixed, temperature is not controlled. All right. C is basically very smooth. Rate of reaction decreases and then decreases again. So it's basically incorrect because rate changes all the time during the course of the reaction. Obviously, D is incorrect because we are talking about the concentration of reactants. And this is the concentration of the product, right? Which is not possible. So right option is B. How come B? Look, initially rate is slow. All right. Then rate becomes faster. And eventually it slows down again. So temperature is not constant throughout the experiment, which means temperature changes throughout the experiment. And if temperature changes, obviously rate of reaction also changes throughout the experiment. That was the criteria, that was the whole concept behind this question, and therefore B is going to be the right answer. Okay, question number 19. Oh God. For a particular reversible reaction, the backward reaction is endothermic. So if backward reaction is endothermic, okay, this must be the case, I must say. A is reacting with B. Since reaction is reversible, represented by this sign, converting into C and D. This delta H. So examiner is saying that backward reaction is endothermic. If backward reaction is endothermic, then obviously forward reaction is exothermic. So delta H is negative for the forward reaction, okay? The activation energy for the backward reaction is 160 kilojoules per mole. Okay, let me arrange the energy profile diagram here. This is energy, and this is progress of reaction. Okay, let's suppose these are the reactants and those are the products. So for exothermic reaction, the energy of product is lower than that of reactant. So this must be C and D, and this must be A and B. And this is going to be the energy profile diagram for you. Okay. So the activation energy for the reverse reaction is basically plus 160. Okay. So this is the reverse reaction activation energy. And since the forward reaction is exothermic, obviously the activation energy has to be from here to here. And this activation energy must be lower than 160. Okay. It can be assumed that the backward reaction proceeds by a mechanism that is an exact reverse of the mechanism for the forward reaction. Which statement about the activation energy for the forward reaction is correct? So the activation energy for the forward reaction is equal to minus 160. It's not equal. It should be smaller than 160. I have given you the instructions here, which is represented by this red line. Now the activation energy for the forward reaction is 0 kilojoule per mole, but less than 160. Obviously, it is greater than 0, but lesser than 160. So I can accept this statement. So B could be the right answer, but let's talk about C and D. The activation energy for the forward reaction is equal to 160. Not equal to, I've told you, it should be smaller. Next is the activation energy for the forward reaction is greater than 160. Forward reaction cannot be greater than 160. Okay. This wrong, and that wrong, which means A, C, B is going to be the right answer. Question number 20. HCN has been detected in the interstellar gas. The molecules below have also been detected in this gas. Which molecule contain the same total number of valence electrons as HCN? Well, this is the formula of HCN. Hydrogen has 1 valence electron, carbon has 4 valence electron, nitrogen has 5 valence electrons. So total you have 10 valence electrons in HCN. So let me get the value of 10 electrons in this option. All right. Hydrogen contain 1 valence electron, nitrogen contain 5 valence electron, oxygen contains 6 valence electrons. So it's going to be 12 valence electrons. So I'm not getting 10, which means A is incorrect. Nitrogen has 5 valence electrons. Hydrogen has 1 times 3 valence electrons. So it's going to be 8 valence electrons. Obviously, B is also incorrect. Nitrogen has 5 valence electrons. Oxygen has 6 valence electrons. So obviously, it's going to be 11 valence electrons in total. So option C is also incorrect. Ultimately, D is going to be the right answer, but let me give you the explanation. Phosphorus belongs to group 15, so it has 5 valence electrons. Nitrogen also belongs to group 15, so it has 5 valence electrons. So you will get total 10 valence electron in this scenario, which is why D is going to be the right answer. Let's start question number 21. The diagram shows the Boltzmann distribution of the energy of the gaseous molecule at a particular temperature. All right, this is the area under the curve. That represents the number of molecules in the sample, and this reflects the activation energy, guys. All right, which statement is correct? if temperature of the gas is raised. If temperature of the gas is raised, obviously curve maximum shifts to the right hand side like this. My bad. Like this, okay? Okay, so that's the right answer. The temperature of the gas is raised. That's the right answer. So if temperature of the gas is raised, the curve maximum shifts to the right hand side. Okay. As a result, this height becomes lower. Height becomes lower. And obviously this proportion is going to be increases. Okay. This proportion is going to be increases. So the height of the curve increases. No, height of the curve not going to increase. It has to be decreased. So option is incorrect. If temperature of the gas is raised, the maximum curves moves towards right hand side. That's right. That's the right statement. So I believe B is going to be the right answer. Let's talk about C. The length of the line labeled X. The length of the line labeled X shows the activation energy. Length never shows the activation energy. Value shows the activation energy. So not length, the value technically, okay? The length of the line labeled Y shows the enthalpy change. No, it's not the enthalpy change. It's basically the activation energy. But again, the length is not going to work. It has to be the value. Okay. So C and D also incorrect. Question 22. The element magnesium and phosphorus are reacted separately with an excess of oxygen. So when magnesium reacts with oxygen, it's going to be converted into magnesium oxide. And when phosphorus is reacted with oxygen, it's going to be converted into P4O10. Okay, which is phosphorus 5 oxide. Each oxide is then added separately to water. When magnesium oxide is added separately into water, it's going to be converted into magnesium hydroxide, which is a weak alkaline solution and it has a pH of 9. When P4O10 is placed in water, it's going to be converted into H3PO4. Okay, it's a strong acidic solution and this will give you of pH 2. So which oxide has having a higher pH? Higher pH is basically magnesium. So magnesium is the right answer. Obviously phosphorus is going to be incorrect. So C and D options are incorrect. Now let's read the remaining part of the question. The same two elements are reacted separately with excess of chlorine. When magnesium reacts with chlorine, it is going to be converted into magnesium chloride. When phosphorus is reacted with chlorine, it is going to be converted into phosphorus pentachloride. Okay. When this chloride, magnesium chloride, is placed in water, according to my lecture, solution becomes acidic with a pH value 6.5. Okay. And when PCl5 is added into water, you will get H3PO4 and HCl. Okay. And this is going to be your acidic solution. And acidic solution means lower pH. And lower pH means a stronger acid. Okay. So oxides giving higher pH, obviously magnesium, chloride giving higher pH, in which case chloride giving higher pH. Magnesium is a case in which pH is 6.5, which is greater than this pH, because if it is a stronger acid, obviously it will give you a pH of 2. In fact, 2 to 3 is going to be the range of this solution pH. Okay. So magnesium is going to be the right answer in this option. This is correct. Option this is incorrect. Right answer is going to be an A. I hope it makes sense to you. Equal volume of saturated solution of magnesium hydroxide, calcium hydroxide, and strontium hydroxide are completely neutralized with dilute sulfuric acid. So when magnesium hydroxide reacts with sulfuric acid, obviously magnesium sulfate is formed. When calcium hydroxide reacts with sulfuric acid, obviously calcium sulfate is formed. When strontium hydroxide reacts with sulfuric acid, it's going to be converted into strontium sulfate. Okay. The water is gently evaporated from each of the resulting solution, leaving the corresponding solid sulfates. Okay. So iska matlab you are getting magnesium sulfate solid, calcium sulfate, and strontium sulfate. All right. Solids. The solid sulfates are completely dissolved in the minimum volume of water needed to produce saturated solution. Saturated solution, highly concentrated. Or solution of known concentration. Okay. Which statement about the volume of water needed to dissolve sulfate is correct? Okay. Now the main thing is we need to dissolve the sulfates. So I have given you some sort of explanation regarding the solubilities of group 2 sulfates. So by the way, down the group, solubility of group 2 sulfates decreases. If solubility of group 2 sulfates decreases, then it means it requires more volume to dissolve. And since magnesium sulfate is highly soluble, so it needs a smaller volume to dissolve. Okay. So calcium sulfate will require the greatest volume of water? No, because strontium sulfate requires more volume. So on the basis of that, C is going to be the right answer. Obviously, Magnesium sulfate will require the greatest volume of water. No, it is highly soluble. It needs smaller volume. They will require the same, not same volume, because one is soluble, one is insoluble. I mean, magnesium sulfate is soluble, strontium sulfate is insoluble. Obviously, it needs more volume. It needs a small volume, so cannot be the same volume. So this cannot be the same. Okay. Question 24. Which statement about the halogens is correct? Iodine cannot behaves as an oxidizing agent. Iodine can react as an oxidizing agent. Okay, so option A is incorrect. Next is the volatility of an element increases. Volatility basically decreases down the group because of the increase in the van der Waals forces. So B is also incorrect. Next is equimolar mixture of chlorine and hydrogen is exploded. Yes, this reaction takes place in the presence of sunlight or UV light. Since hydrogen and chlorine both are reactive, so reaction is going to be exploded. Only one product is formed. Obviously, only hydrogen chloride is formed. So this might be the right answer. But let me tell you about the option D as well. When concentrated sulfuric acid is added to solid sodium bromide, hydrogen sulfide is one of the product. Obviously, when sodium bromide reacts with sulfuric acid, hydrogen sulfide is not going to be the product. In fact, it's going to be sulfur dioxide. Hydrogen sulfide product is obtained when sodium iodide is reacted with concentrated H2SO4. So this statement is also incorrect. Okay. Question 25. When concentrated sulfuric acid is added to solid sodium bromide, bromine gas is produced. Okay. Along with the other products. Okay. Now in this case, bromide is a weaker reducing agent and concentrated H2SO4 is a strong oxidizing agent. Okay. Now the next part of the question is, when concentrated sulfuric acid is added to solid sodium chloride, hydrogen chloride and sodium hydrogen sulfate are produced, which means in this reaction, concentrated H2SO4 is a weak oxidizing agent. Also, sodium chloride, so chloridine. No, it's not weaker. If chloride is a weaker, obviously bromide is a stronger reducing agent. Okay. Chloride is a weaker reducing agent. Weaker reducing agent. So that's a comparison basically. So chloride and bromide, two halide zymes are involved in this reaction. One is stronger reducing agent because in this scenario it is reacting with H2SO4, but this is weaker reducing agent because it is not reacting with concentrated H2SO4. So bromine is less volatile than chlorine. Bromine is less volatile. Volatility has nothing to do with the oxidizing ability of sulfuric acid, which means it's incorrect. Hydrogen chloride is a weak acid. Wrong. It is a strong acid. Sulfuric acid is not an oxidizing agent. Sulfuric acid is an oxidizing agent. So this statement is also incorrect. Obviously, D is going to be the right answer. Let's talk about D. Bromide ion is a stronger reducing agent. Yes. Then chloride ion. Yes. All right. So D is going to be the right answer. Question 26. Which statement about the oxides of nitrogen is correct? Where we have two oxides of nitrogen. One is nitrogen monoxide, the other one is nitrogen dioxide. Nitrogen monoxide is formed through lightning. during thunderstorm, all right? And nitrogen dioxide is formed through internal combustion of engine, okay? So during lightning storms, atmospheric oxygen and nitrogen combine to form oxides of nitrogen. That's the right statement, because when nitrogen reacts with oxygen during thunderstorm, it's going to give you nitrogen monoxide. That's the right answer. So I must say A is the right answer. Let me check the other options. In a catalytic converter, nitrogen monoxide is removed by the reaction with carbon dioxide. By the reaction with carbon dioxide, not carbon dioxide, it must be carbon monoxide. Okay, so this statement is wrong. Next is in car engines, the restricted supply of oxygen eliminate the possibility of the formation of oxides of nitrogen. Restricted supply means limited supply. Limited supply will give you nitrogen monoxide instead of nitrogen dioxide. So this again is might be the incorrect option. Last but not the least, in the atmosphere, nitrogen monoxide react with sulfur dioxide. By the way, nitrogen monoxide cannot react with sulfur dioxide. Why? Because I've told you in nitrogen sulfur, in homogeneous catalyst, that nitrogen dioxide is an oxidizing agent. It oxidizes sulfur dioxide into sulfur dioxide and reduces itself. Okay, and then this nitrogen monoxide is further air oxidized in the atmosphere and will turn to nitrogen dioxide, right? So reaction starts from NO2 and you will get NO2 at the end of the reaction, which means NO2 will serve as a homogeneous catalyst. We have discussed this in nitrogen and sulfur. We have discussed this whole mechanism, whole reaction in reaction kinetics chapter as well, all right? So nitrogen monoxide cannot produce sulfur dioxide or cannot oxidize sulfur dioxide into sulfur dioxide, but NO2 can, which means D is also incorrect. Question 27. Structural isomerism and stereoisomerism should be considered when answering this question. All right. 2-bromopentane, which is your alkyl halide, is heated with an excess of ethanolic. Ethanolic solution of hydroxide means elimination reaction takes place. When any alkyl halide undergoes elimination, always alkene is formed. So 2-bromopentane is your alkyl halide. This is your 2-bromopentane. And when it undergoes elimination, obviously you will get pentane, sorry, pentane. Okay, this one. 1, 2, 3, 4, 5. Okay. So either you will get in fact 2 different alkenes here. Either you will get pent 1E, 1, 2, 3, 4, 5. This is pent 1E. Okay, I mean to say elimination takes place from the hydrogen of this beta carbon atom. Okay, now if elimination takes place from the hydrogen of that beta carbon atom, you will get pen2ene. And this pen2ene gives you both cis and trans. So technically we have first structure, we have second, and we have third one. So in total we have 3 different hydrocarbons, and therefore C is going to be the right answer. Okay, which compound is secondary alcohol that can be dehydrated to form an alkene of Mr70? By the way, option A is incorrect because it is 3-degree alcohol. That means it is not a secondary alcohol. All right, but you know this is the secondary alcohol because it is attached to only one hydrogen. This is attached to only one hydrogen, also secondary alcohol. This is attached to only one hydrogen, which is also secondary alcohol. So all of them are secondary alcohol. So how many carbon atoms? 1, 2, 3, 4, 5 carbon atoms. Let's talk about the hydrogen atoms. 3 plus 3, 6, 6 plus 1, 7, 7 plus 1, 8, 9, 10, 11, 12. 12 hydrogen atoms and 1 oxygen. If I'll remove water, I mean 2 hydrogen and 1 oxygen, so I'll get C5H10. C5H10 is 12 times 5 plus 10. So 60 plus 10 is basically 70. So the MR of this alkene is 70 after the removal of water. And that's what the examiner wanted to find out. So that's your 70. So answer is B. But let me give you another options. 1, 2, 3, 4 carbon atom. 3 plus 2, 5. 5 plus 1, 6. 6 plus 1, 7. 7 plus 3, 10. And 1 oxygen. When you remove water, you will get C4H8. 12 times 4 plus 1 times 8. You will get 56. Obviously, it's not 70. Again, it is incorrect. Cyclopentanol is the option B. Count the number of carbon atoms. We have 5 carbon atoms. How many hydrogen atoms? 2, 4, 6, 8, 9, 10. Let me check calculation. 2, 4, 6, 8, 9, and this one is 10. So C5H10O, I'll remove water. So after that, I will get C5H8. MR find out करते हैं. C5H8, 12 times 5 plus 8 is going to be 68. So obviously, it's not 70 again. So D is incorrect. Question number 29. The conversion of propane 1-ol into propane 2-ol can be completed via two-stage synthesis. So I need to convert propane 1-ol into propane 2-ol via two-step synthesis. Okay. In the first stage is to heat the propane 1-ol with concentrated sulfuric acid. That's your elimination reaction, which is also called dehydration. And when alcohol undergoes dehydration, you will get an alkene. So this is your propane 1-ol, CH3, CH2, 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 OH, propane 1-ol. Oh my goodness, propane 1-ol, CH3, CH2, CH2, OH. This is your propane 1-ol. So when you add sulfuric acid in it, it undergoes dehydration. And because of that dehydration, you will get an alkene. And this could be propene. Okay. This is my first step. In the second step, this propene is treated with steam in the presence of phosphoric acid, which acts as a catalyst, 60 atmospheric pressure and 300 degrees Celsius temperature. So I'll get propane 2-ol as a major product. Why? Because steam is an unsymmetrical reagent. Propene is an unsymmetrical alkene. So since unsymmetrical alkene and unsymmetrical reagents are involved in the reaction, which is why we will follow the Markovnikov rule. And according to Markovnikov rule, major product is going to be propane 2-ol. So from propane 1-ol to propane 2-ol, we need these two types of reagents and conditions. So examiner is asking which reagent would be needed to complete the second stage. So for second stage, I need steam and acid. The steam and acid is C, therefore C is going to be the right answer. Question number 30. Which type of reaction happens during the hydrolysis of 2-bromopropane? This is alkyl halide. When alkyl halide undergoes hydrolysis, obviously elimination reaction, nucleophilic substitution reaction takes place. Electrophilic addition takes place in alkenes, which is wrong. Free radical substitution reaction takes place in alkanes. So 2-bromopropane is not an alkane, it is an alkyl halide, obviously wrong. Nucleophilic addition takes place both in aldehyde and ketone. It is an alkyl halide, again wrong. The right answer is going to be D. A mixture of ethane and an excess of chlorine is exposed to UV light. How many different products, each containing only 2 carbon atom and at least 1 chlorine atom per molecule can be formed? I think I have solved this question either in variance 11 of 2023 or variance 12 in 2023. So I have given you the working in that particular paper. So you can check it from there, but answer is going to be B. Let me solve it on separate papers because it requires a lot of working. So when ethane is treated with excess chlorine, obviously substitution reaction takes place. And we have discussed this whole concept in the class as well. All right. I hope you remember that. So when 1 chlorine is attached, it's going to be the first isomer. Second possibility, that we have 2 chlorine atoms in the molecule. When we have 2 chlorine atoms in the molecule, we will get 2 different situations. First, both the chlorines are attached to the same carbon atom. It might be possible that 1 chlorine is attached to this carbon and other one is attached to this carbon atom. So chlorines are attached to adjacent carbon atom. That's the possibility. So it's my second, it's my third. Now the fourth possibility, when we have 3 chlorine atoms in a molecule, might be it is attached to the same carbon atom, right? Or it could be the possibility that 2 chlorines are attached to this carbon, whereas 1 chlorine is attached to this carbon atom. So this is going to be your another possibility, fifth one. Now this one is sixth. What if you have 4 chlorine atoms? 3 is attached to this carbon and 1 is attached to another carbon atom. So this might be the possibility that this carbon has 2 chlorine atoms, whereas this carbon also has 2 chlorine atoms. So this might be the possibility. What we have 5 chlorine atoms. So if we have 5 chlorine atoms, obviously 3 chlorine atoms are attached to this carbon, whereas 2 chlorine atoms are attached to that carbon atom. That's the only possibility left in this. There is no other possibility exists. What if we have 6 chlorine atoms in the molecule? Obviously 6 chlorine atoms are attached to this these 2 carbon atoms, so we'll get the structure like this. So how many isomers so far we have got? 9 isomers we have. So that's why 9 is the right answer for question 31. Oh my goodness, that's a lengthy question. When 1 methyl cyclohexene reacts with bromine, the product is X. Okay, this is 1 methyl cyclohexene reacts with bromine, the product is X. Okay, if the product is X, then it means bromine is attached to the adjacent double bonded carbon atom. So I will attach 1 bromine here, and I will attach 1 bromine here. And you know what? This is going to be the chiral carbon atom. This is going to be the chiral carbon atom. See, we have 2 chiral carbon atoms. So total 4 stereoisomers are obtained from this. So X gives you 4 stereoisomers, right? And examiner is saying that X is a mixture of 2 stereoisomer, which is wrong. X is a mixture of 2 stereoisomer, which is wrong. X is a mixture of 4 stereoisomer, which is right. X is a mixture of 4 stereoisomer, which is right. So option A and B obviously are out from the competition. So C and D could be the right answer. Let's talk about this reaction. Okay. When 1 methyl cyclohexene reacts with HBr, the major product Y is formed. Obviously, it is an unsymmetrical alkene. It is unsymmetrical reagent. So we need to apply the Markovnikov rule, and so we'll get the major product. So the major product is going to be like this. Oh, So this is H and this is H. This is Br. So this is the major product, guys. I hope it makes sense to you. What could be the minor product of this reaction? The minor product of this reaction could be like this. Wait. Let me write the minor product as well. So the minor product could be like this. So this product follows the Markovnikov rule, whereas this product didn't follow the Markovnikov rule. Since we need the major product, examiner is talking about the major product, so we need to cancel this one. Okay. Whew. So do we have chiral carbon atom? CH2 no chiral, CH2 no chiral, CH2 no chiral, CH2 no chiral. This is CH2 no chiral. This is CH3 no chiral. This carbon could be chiral. No, it is not chiral because guys, this is symmetrical cyclic ring. Both these two groups are same, which means it is a symmetrical cyclic ring. If we have a symmetrical cyclic ring, this carbon cannot show optical isomerism because these two groups are similar groups, right? So this is not chiral. So there is no stereoisomerism exists in Y, right? The Y does not have stereoisomers. This is right. Y is a mixture of four stereoisomers. Wrong, because of the absence of chiral carbon atom. It is not possible to have four stereoisomers, and therefore it could not be the right option. And therefore C is going to be the right answer. Okay, I hope it makes sense to you. Question 33. T is an organic compound which contains 66.7% by mass of carbon. T also contains one atom of oxygen per molecule. T reacts with alkaline ecosardine to produce a yellow precipitate. So that's a iodoform test. An iodoform test appears when we have CH3 with secondary alcohol group, that is CHOH, or either we have CH3 CO group, that is methyl with ketone. All right. So let's talk about option A. We have propane. Propane means 3 carbon atom, 1, 2, 3. 2-ol means OH is attached to the second carbon. This methyl means it needs to be attached to this carbon. So this option has no CH3 CHOH group, which means this compound cannot give iodoform test, and therefore A is incorrect. C is also incorrect because butanol has no CH3 CO group. Now the competition exists between B and D. Let's talk about B. This is CH3. This is CH, OH, CH2, and this is CH3. Now B has CH3 COH OH group, which means it can give you yellow precipitates of iodoform, right? Let's talk about D. D is butanon. Butanon has also CH3CO group, which means it can also give you positive test of hydroform. Okay. So this group will give you iodoform test. This group will give you iodoform test. So both of them have uh, same sort of test, but we need to find out the percentage by mass of carbon in both the compounds. So the molecular formula of this compound is C4H10O, whereas the molecular formula of this compound is C4H8O. The MR of this compound is how much? 74. 12 times 4 plus 16 plus 10, 74. Yes, MR for this compound is 74, and the MR of this compound is how much? 12 times 4 plus 8 plus 16 is going to be 72. So let's find out the percentage by mass of carbon in both the compound. The percentage by mass of carbon, how many carbons we have? 4 to 12 into 4 into 12 into 4 divided by 74 into 100. So I'll get what? This is going to be 64.8%. Examiner is asking for 66.7, which means it is also incorrect, and therefore D is going to be the right answer. But let me give you the calculation for D. We need to find out the percentage by mass of carbon in D, that is in butanon. So we have an AR of carbon, which is 12. We have 4 carbon atom into 4 divided by the MR, which is 72. Percentage, for percentage determination, we need to multiply by 100. So 12 times 4 divided by 72, I'll get 66.66%, that is 66.7%, and therefore D is going to be the right answer. Okay, I hope it makes sense to you. Gosh, there are a lot of calculation, guys. Which statement about the butanon is correct? Butanon can be dehydrated by concentrated sulfuric acid. Absolutely incorrect. Butanon is a ketone, and ketone cannot dehydrate. Okay. Next, butanon gives a positive result with Tollens reagent. Butanon is a ketone, and ketone never reacts with Tollens reagent. So reaction cannot take place. Option B is incorrect. Phew. Butanon reacts with HCN. Yes, it do react with HCN by an electrophilic addition reaction. So this is incorrect again, because butanon is a ketone, and ketone always undergoes nucleophilic addition reaction instead of electrophilic addition. Electrophilic addition, in fact, takes place in alkenes. Okay, so C is incorrect, and therefore D is going to be the right answer. Okay, so let's start question number 35. Question 35 says that methyl butene reacts with HBr. Obviously, it is an unsymmetrical alkene. It is unsymmetrical reagent. Obviously, we need to apply Markovnikov rule on both these things, right? And Markovnikov rule always follows this most stable carbocation, all right? So we need to find out which carbocation is most stable in this reaction. At room temperature to produce compound X as a major product. The examiner is talking about the major product. Obviously, examiner is looking for the most stable carbocation. So let's start the first. This is the first part of the question. So let's solve this first part. Methyl butene. Methyl butene. 1, 2, 3, and this one is 4. This is methyl butene. And this methyl butene, we have different situation in terms of bond breaking. First, if I'll shift pi bond onto this carbon, then this carbon becomes negatively charged and this carbon becomes positively charged. So this is CH3, CH3. This becomes positively charged. This is CH minus, and this is CH3. Okay. And when I'll shift pi bond to this carbon, obviously this carbon becomes positively charged and this becomes negatively charged. Then CH3, CH3 negative, and this is CH positive, and this is CH3. All right. Now carbon carries positive charge and it has no hydrogen, which means it is tertiary. So this is tertiary carbocation, which is 3-degree carbocation. And if carbon carries positive charge and it has one hydrogen atom, then it means it is secondary carbocation, which means it is 2-degree carbocation. All right. And you know that tertiary is more stable than 2-degree. Tertiary carbocation. Hold on. Tertiary carbocation is more stable than 2-degree, and 2-degree is more stable than 1-degree, which means reaction followed this route instead of this one, right? So if I'll use HBr, obviously I'll get the product like this: CH3, C, CH3. Now this CH has a negative charge. Obviously, electrophile will shift onto this carbon, whereas bromine shift onto that carbon atom. Okay. So bromine is going to be attached here, and hydrogen is shifted on CH, so it becomes CH2, and this CH3. This is our major product, which was given in as an instruction in the question. All right. So this was the major product examiner was talking about. And this is your compound X, guys. My goodness, that's a lot of explanation and a very minimum space. Now in the second, that is the first. Okay. Now compound X reacts with KCN in ethanol to produces compound Y. This is the second part of the question. My God, that's a huge lot of working actually. Then CH3, C, CH3, Br, CH2, CH3. If you react this compound with KCN in ethanol, obviously nucleophilic substitution reaction takes place, and as a result, CN is replaced, or bromine is replaced by CN. This is going to be your CN. This is CH2. This is CH3. God, this one is first. This one is second. Let's talk about the third statement. Compound Y hydrolyzed with acid to produce Z. By the way, this is compound Y. Now the third and the last statement is that we have compound Y, CH3, C, CH3, CN. This is CH2. This is CH3. So what we are doing is we are doing acid hydrolysis. So when we do acid hydrolysis, CN is converting into CWH directly. So this is CH3, C, CH3. This is CWH. This is CH2. And this is CH3. My God, that is compound Z. That's the question. Whew, all right. What is compound Z? My goodness, this is compound Z. So select the longest possible carbon chain, guys. So we need to give the priority to carboxylic acid. So this must be the, oops. This must be the longest carbon chain. Let me give you the number. First, second, third, and fourth. So 4 carbon atom has a long chain with carboxylic acid, which means it is butanoic acid. And obviously, this is incorrect. This is incorrect because it is pentanoic acid. Pentanoic acid, whereas we are getting butanoic acid. 1, 2, 3, 4 carbon atom acid is butanoic acid. So butanoic acid is here. Butanoic acid is here. Now on the second carbon atom, we have 2 methyl groups, so 2, 2 dimethyl. So this is 2, 2 dimethyl. So answer is going to be an A. B is again incorrect because 2 methyl group are attached to the same carbon atom. Okay. That's tricky. Okay. Compound Q can be hydrolyzed by HCl. The two products of this hydrolysis have the same empirical formula. Okay. This is ester. This is ester. This is also ester. So these 3 compounds can easily hydrolyze in the presence of acid. But this is not ester, which means it cannot hydrolyze. So let's remove, or it's out from the competition. So D option is incorrect. My goodness, let's talk about option A. This is going to be the acid part, and this is going to be the alcohol part. So acid is going to be CH3 COOH. The molecular formula of acid is C2H4O2. So if you divide by 2, you will get the empirical formula, which is CH2O. The alcohol part is ethane 1,2-diol, which is CH2OH, and then CH2OH. We have 2 carbon atom. We have 4 plus 2, 6 hydrogen atom, and we have 2 oxygen atom. So if we divide by 2, I'll get CH3O. So both these empirical formulas are different, which means A is also incorrect. Okay. Let's talk about option B. This is going to be the acid part, and this is going to be the alcohol part. Okay. So acid is going to be CH3 COOH. Its empirical formula is going to be CH2O. Whereas alcohol is basically CH2OH, CH2, and COOH. How many carbon atoms here? 1, 2, 3 carbon atoms. How many hydrogen atoms? Let's count. 2 plus 2, 4, 4 plus 1, 5, 5 plus 1, 6. And we have 3 oxygen atom. Divide by 3, so you will get CH2O. So both these, so this compound gives you the same empirical formula. I believe B is going to be the right answer. Let me double check. Let me double check. Yeah. Let me give you the option C. Let me solve option C. Option C. This is going to be the acid part. So propanoic acid would be the product after hydrolysis. And this is going to be the alcohol part, which is propanol. CH3, CH2, CH2OH. Now, total carbon atoms, we have 3. 3 to 5 plus 1, 6 hydrogen. We have 2 oxygen. So we really can't find the empirical formula from here. Okay. So we can't halve this because this is 3 carbon atom. So this is the empirical formula. We have 3 carbon atom, 3 to 5, 5 plus 2, 7 plus 1, 8. we have 8 hydrogen atoms and we have 1 oxygen atom. Oh, so that's not the empirical formula again. These two are different empirical formulas. Okay, so C is also incorrect. Question number 37. My goodness. An unsaturated carboxylic acid. Unsaturated means it has a double bond between carbon atom. Reacts with alcohol X to form an ester. The structure of the ester is shown. I've told you that the first part belongs to acid. This is your acidic part. And this is going to be the alcohol part. So if, all right. So what we can do is, which geometrical isomer is shown in this ester? Oh, that's an easy task. See, this double bonded carbon atom, we need to check. This is hydrogen atom. This is also hydrogen atom. So if two similar groups are attached to the same side of the double bonded carbon atom, obviously it's going to be cis. Okay. So this is cis, trans possible nahi hai, to option C and D are incorrect. Okay. Class of alcohol X belongs to. So if I'll break the bond from here, obviously I'll get the alcohol. Alcohol is basically like this. This must be the alcohol. And this is propane 2-ol. Basically, it is 2-degree alcohol, also called secondary alcohol, because OH is attached to carbon, and this carbon has only one hydrogen, which means it is secondary alcohol. So secondary alcohol could be this, secondary alcohol could be this. So right answer is going to be Na. Okay. My goodness. Which two-step process converts cyclohexanol into cyclohexane 1,2-diol? The issue is two-step process. Okay, this is cyclohexanol, which is an alcohol. So first, what we need to do is we need to dehydrate it by using dehydrating agent like aluminum oxide under heat. So you will get cyclohexene. Okay. Now check, we have 2 OH and 2 OH, I mean diols are always formed when alkene is treated with cold dilute acidified KMNO4. And as a result, you will get this product, 1 OH here, 1 OH here, that is your diol. Okay. So we are looking at aluminum oxide under heat, which is here, here. So this must be incorrect, this must be incorrect. Why this option is incorrect? Because this reagent is applicable for the elimination of alkyl halide. And since we have alcohol, so I'm not going to use it in this, and therefore C and D is incorrect. And the next is cold dilute acidified KMNO4. So cold dilute acidified KMNO4 is this, cold acidified KMNO4 is this. So right answer is going to be Na. Okay. Question 39. My goodness. In polymer G, every carbon atom in the polymer chain is bonded to one hydrogen atom and one methyl group. Okay. Which alkene could be polymerized to make polymer G? Okay. One carbon has one hydrogen and one methyl. So if we have an alkene monomer and it has one hydrogen and one CH3, one hydrogen and one CH3, then it means it's going to be butene. That's the only option left, and therefore B is going to be the right answer. Why not A? Because this carbon has 2 hydrogen, whereas this carbon has 1 hydrogen and 1 ethyl group. So this structure doesn't satisfy the situation which is given in the question. 1H and 1 methyl, 1H and 1 methyl not possible. 1H is here, but 1 methyl is not here, which is why A is incorrect. And same criteria for methyl propene and propene. Oh, the last question finally. The mass spectrum of compound X has molecular ion peak, M+1 peak, and M+2 peak. Other peak are also present. Peak M is the fine. Peak M has a relative abundance of 15 times that of peak M+1. Peak M and M+2 are of equal height. What could be compound Q? Okay. First of all, we know the abundance of molecular ion peak and M+1 peak. So by using the abundance, I can find the number of carbon atom in this compound X. So 100 over 1.1, abundance of M+1 peak, which is 1, and abundance of M+1 peak, which is 1, and abundance of molecular ion peak is 15 times higher, which is 15, right? All right. So number of carbon atom is going to be 6. So we have 6 carbon atom in this compound. On top of that, one more thing. This compound has M and M+2 are of equal height. Equal height means equal proportion, and equal proportion means presence of bromine. Means bromine. So if bromine is present in this compound X, obviously option A and option B is incorrect because both of them contain chlorine, which is not possible. If chlorine is there, the height should be 3:1 instead of 1:1. Okay. And equal proportion means ratio is going to be 1:1. Now competition exists between C and D. So what could be the right answer? We need to find out the total number of carbon atom in both the structures. Let's talk about C first. Hexane 1, 2, 3, 4, 5, 6. 2 bromo, 2 methyl. This is 2 bromo. This is 2 methyl. Let's count the number of carbon atoms now in this. 1, 2, 3, 4, 5, 6, 7 carbon atoms. So this has 7 carbon, whereas we had 6 carbon atom. So obviously C is also incorrect, and obviously D is going to be the right answer because butane has 4 carbon and 2 methyl has 2 carbon. So 4 carbon plus 2 carbon is becomes 6 carbon atom. Let me give you the structure. Butane has 4 carbon atoms. 1, 2, 3, 4. 3 bromo. 1, 2, 3 bromo. 2, 2 dimethyl. This is 2, 2 dimethyl. Check carbon. 1, 2, 3, 4, 5, 6 carbon. That's why D is the right answer. We are done with this chapter. I mean, paper. Thank you very much.